So in this section we'll discuss managing partitions. Partition tables and index provide a convenient way to manage very large sets of data and do so effectively. However, the design of any partition function or scheme may need modification over time. Changing data access patterns may require us to adjust the partitions in a database. And SQL Server 2012 provides the ability to make these changes rather easily. SQL 2012 also enhances the Manage Partition wizard. But don't get too excited. We're going to show you how to do it through T-SQL. Anybody can use a wizard. We all realize that as time goes on, it may be necessary to adjust tables and indexes within the databases based on how things are used. And SQL Server provides that functionality through T-SQL. We can change the boundaries and the number of partitions, and we can alter the partition scheme to include new file groups. We can make a non-partition table a partitioned one. We can take a partition table and convert it back to a non-partition table, add or delete data from particular partitions, or move data between partition tables. If we want to add or delete partitions from a table or index, what we really have to do is modify the underlying partition function. To create a new partition, we have to divide an existing partition into two segments, and then we have to redefine the partition boundaries. If we want to merge partitions, it really means we're going to take two partitions and effectively create one out of them. T-SQL has an alter partition function statement, and that allows us to add or subtract a partition at a time. If you have a need to add or remove multiple partitions, you might want to think of a different approach. One way of doing it would be to create a brand new partition table using a partition function that maps your new needs, and then transfer the data. You could also create a clustered index on a heap. You could drop and rebuild the partition index using the create index statement with the drop existing equal on clause. Or you could simply use the alter partition function statement repeatedly, one for each modification you need to make. The syntax for the alter partition function is as follows. Alter partition function, and we give the partition function name, and then we either tell it we want to split or merge partitions, that would be the split range or merge range, and give the new boundary values. There's a warning that comes with this though. Multiple partition tables and indexes can use the same partition function. So if you modify the partition function, you're going to affect all the tables and indexes that actually use that function. So be careful. What do we need to do if we want to split partitions? Adding a partition to a partition table requires us to actually split an existing one. We have to break it into two segments. After the split, those partitions now have newly defined boundaries. We'll use the split range statement within the alter partition function to divide an existing partition. Here's an example. Let's alter the partition example range right PF, and we'll split a range indicating that the new boundary value should be 1 million. So what does that really look like? Here you can see we have an example table defined with multiple partitions. And in the original definition, we had the final partition, the last partition, contained values that were greater than or equal to 100,000. Now we want to include values that are greater than or equal to 1 million, and we want to put those in a specific partition. And what we've done here is simply indicated to SQL through the alter partition function statement that we're going to split the partition, and the new boundary value is 1 million. And in essence, what happens is we end up now with two partitions, one with values greater than or equal to 1 million, which is what we wanted, and now we have this other partition defined, this result of the splitting, that will now contain values greater than or equal to 100,000, but less than 1 million. And as I said, if we consider the partition function defined earlier, The last partition needs to be split in order to accept those values that are greater than 1,000,000. SQL Server's alter partition function does just that. There are some guidelines for splitting partitions, so keep these things in mind. The split range value must differ from existing boundary values. You can't reuse the values defined earlier. SQL places the split range boundary value in the new partition. You must have a file group marked as next used to hold the new partition. If SQL can't find this, you have to use the alter partition scheme prior to altering the number of partitions. So now let's consider the other direction. How do we merge two partitions? If we want to remove a partition from a partition table, SQL Server needs to merge two existing partitions into one. Again, we're going to use the alter partition function statement, this time with a merge range to do the work. So if we want to combine partitions whose boundary values are between 1,000 and 99,999, we'll need to alter the partition function as follows. Alter partition, give the name of the function, merge range, and give the value that we want. In this case, 10,000. So let's see how this works. So here we have our partitions laid out. You can see that the two partitions in the middle have actually merged. We now have a single partition who's holding values greater than or equal to 1,000 and less than 100,000. But here's a tip that I'd like you to remember. How do you figure out in your head which two partitions are actually going to merge? I like to remember that when two partitions merge, you want to look at the range definition of the partition function, because when they are merged by SQL, functions that are defined as range left will merge with the partition to the value's immediate right. If it's range right, the merge will occur with the partition to its immediate left. So a little bit of a tip there to remember how things actually work underneath. It's kind of an opposite. Range left, it's going to move right. Range right, it's going to move left. Guidelines for merging partitions are as follows. The merge range value already exists in the partition function. Unless the file group that held the original boundary value contains more than one partition, or if it's marked as next used, SQL Server automatically removes the file group from the partition scheme. And the merged partition will live in the file group that did not originally contain the boundary value. That's that example of if it's defined left, it's moving right. If it's right, it's going to move left. Now let's talk about switching partitions. SQL actually gives us the ability to switch in or switch out partitions into a table. We do this through the alter table switch statement. And using that statement, we can accomplish the following types of modifications. We can add another table as a partition to an existing partition table. We can move a partition from one partition table to another. We can convert multiple partitions within a table to create a single table. And while T-SQL provides that functionality to perform the tasks, there are lots of specific requirements with partition tables and indexes that you need to be aware of. So if you want to do a switch, make sure the following are true. If you're going to transfer data between two tables, both tables must exist prior to the operation. The target partition has to be empty. To switch partitions to create a non-partition table, make sure the table receiving the partition already exists and is empty. Kind of makes sense. When switching partitions between two partition tables, both tables must have the same partitioning key. Both the source and target tables must be structurally equivalent. This means that the columns defined are in the same order, they have the same names, data types, length, precision, scale, collation, nullability, primary keys, clustered and non-clustered indexes. So you're getting the idea here that this, while very convenient, is by no means trivial. We also have to make sure that there's no XML or full-text indexes on the tables. No primary foreign key relationships between the source and target are allowed. If check constraints exist, they have to be identical for both the source and the target. Each table, as well as their large value columns, varchar max, text, and text image. The indexes and partitioned indexes need to reside in the same file group. And neither table can be a replication source. Now remember, switching data between partitions really does usually occur between identical table structures. And a common example of this is if you're going to archive some transactional data, perhaps to a data warehouse. SQL Server 2012 has a wizard that they've actually enhanced. It's called the Manage Partition Wizard, and that can simplify some of the switching in and switching out. So take a look at Books Online for more details. The syntax for switching out a partition is as follows. Alter table, we give it a table name. Switch a partition from one location to a target table in another location. So we're going to give it the partition number that we want to switch out, and we're going to indicate what target table to go to. And if that target happens to also be partitioned, we'll give the partition number it should use on the target. So as an example, let's take a look at the following T-SQL, which will archive data from a partition table and put it in a non-partition table. It's pretty straightforward. We're going to alter the table called example table, and we're going to switch out partition 2, and we're going to move it to a structurally identical table called non-partitioned example table. And once we execute that statement, if all of those conditions are true, primarily being structurally equivalent along with your data types and order of the columns and so forth and so on, then all of the data from partition 2 in example table will move to the non-partition table. What do we do if we need to modify a partition scheme? As we know, partition schemes map partitions defined by the partition function to specific file groups. When you modify a partition scheme, it really means adding a file group or designating a file group to hold an additional partition. We can use the T-SQL alter partition scheme to perform those operations. It's an alter partition scheme. We give it the partition scheme name, and we indicate which file group is next used. That will instruct SQL to start putting data into that file group. That syntax requires us, though, to have a file group marked as next use so that it can hold the data for the new partition. If there already exists a file group marked as next use, then the file group name becomes the newly marked file group. However, if the file group name is not an empty file group, now realize that that file group will be holding multiple partitions. But here's a warning. The syntax indicates that the file group name is optional, but don't leave it out. If you don't specify the file group, the partition scheme will lose its next used attribute, and SQL will return a warning. So now let's talk about some maintenance tasks, specifically backing up partitions. If you want to back up one or more partitions, all you need to do is recall their underlying structure. Partitions will map through a partition scheme to one or more file groups. So backing up partitions really means just backing up one or more file groups. And backing up file groups is pretty straightforward, but keep some things in mind. For read-write file groups, make sure the database recovery model is set to either full or bulk logged. If you have a database with a simple recovery model, it'll only support backing up read-only file groups. And in order to perform differential file group backups, complete a full backup of the file groups first. One or more backup devices must exist prior to performing the backup. And here's a tip. Creating a file group for each partition in a database provides the greatest flexibility. By doing that, it allows for either full or differential backups on any partition at any time. You use the normal T-SQL backup database statement to back up selected file groups, and a simplified version of the backup database statement is right here. We're going to do a backup database, give it a name, list the file groups that we want to back up, and point it to the right device. So for example, if we wanted to back up our Q1 sales data for year 2007, we could use a device name sales 2001 Q1, and the syntax would be this straightforward. And the syntax would be this simple. Backup database AdventureWorks 2012, file group, sales 2001 Q1 file group, back it up to that device. Now let's talk about some performance considerations. One of the benefits of partition tables and indexes is we're supposed to see some improvement in query performance. We're going from very large amounts of data to smaller buckets. That should get us some better performance. So if we take some time to design those partitions based on how the data will be accessed, then we can hopefully achieve this benefit. Specifically, when we talk about joining queries, we have to understand that joins between two tables are very common. The joins occur between columns that have equivalent values. And partition tables will actually perform better if the join column is a partition key. You can get even better performance when the tables or indexes are co-located, meaning that the same partition function or partition functions are essentially the same. Co-location will occur when the partition functions used have the same number of parameters and each parameter is of the same data type. Doesn't mean that the columns have to be named the same or anything like that. It just means that they are structurally equivalent. Also, co-location will occur when each partition function defines the same number of partitions. And of course, the partitions have to have the same boundary values.